Hi, Bismillah ar-Rahman ar-Rahim. I welcome uh, all engineering students, especially the students of the University of Khaja Farid, University of Engineering and Information Technology, in the course of Engineering Dynamics. This is lecture number 12 regarding this course. Dear students, we have discussed the curvilinear motion in a plane. Today we will discuss the curvilinear motion in space. First in the Cartesian coordinates, then in the cylindrical coordinates, and then in the spherical coordinates. I'll solve some of the solved examples inshallah today and the unsolved problems. Okay, the space curvilinear motion. The example of space curvilinear motion, if you see, if you go to the amusement park, if you see, that is the motion in this in a curve like this. That is basically a curvilinear motion. Similarly, there are a lot of swings. It's a moving like this, right? And that is also a curvilinear motion. If you see the motion of a impeller, right, which is moving, also some force is also in the vertical direction, that is also curvilinear motion in space, right? So similarly, the motion in a plane, that is also a motion, the curvilinear motion in space. So first of all, we discuss this curvilinear motion into rectangular coordinates. Let's see, there's any point P which is at a distance r from this origin, and of course the Cartesian coordinates I set, this is x I unit vector, this is y unit vector j, and this is z unit vector k. If I show the r, and of course r is as a position vector, if these coordinates are the coordinates of the P are x, y and z, then therefore the r will be xi plus yj plus zk. If you want to take the velocity, you just take the derivative of this, x dot of I, y dot of I, z dot of I. X dot is the velocity in x direction, y dot is the velocity in y direction, and z dot is the velocity of that particle in the z direction. If you take the second derivative, we get the acceleration. Similarly, x double dot plus y double dot plus z double dot. And if you need to find the magnitude of velocity, you take the x dot square plus y dot square plus z square. You get the velocity. Similarly, x dot square plus y dot x double dot square plus y double dot square plus z double dot square will give you the acceleration. And if you see here, I also made the three other axes, like if you see this one, if this particle, this is a radial direction, right? This is the theta direction. This is the theta direction is the movement on the plane in the right this one. So this is the theta direction, right? And this is phi is the movement along the along this vertical direction, right? This is movement of r, and that is basically the phi direction. So we will discuss in detail today, but this is very simple one, is the Cartesian coordinates. Now the cylindrical coordinates, as we have discussed the polar coordinates, this is r and theta in the plane, and now there will be cylindrical coordinates. We have r and theta, that is on the base. If you see there's any particle P, how I reach this at this point, I move some value of r, then the angle theta, then I move in the z direction, that I reach at point P. This is basically the cylindrical coordinates. So only z will be added in the vertical direction. If I write the position vector will be r in the r direction, and of course z in the k direction. If I write the velocity vector that we have already driven for the planar coordinates, is r dot er is a velocity in the radial direction, r theta dot velocity in theta direction, and z dot k will be added in the y direction. So this is vr r dot theta, and we find the velocity vr square plus theta square plus vz square. Similarly, acceleration, we have also derived this relation for the planar, is r double dot minus r theta dot square is the radial direction acceleration, r theta double dot plus 2r dot theta dot e theta, that is the theta direction, and z double dot k is the new component added in the z direction, and take the square of all these acceleration, you get the total acceleration. Dear students, please, students will have some problem when they are talking about space. This is just like this is the r direction, and move on the plane, and that is the the theta direction, and then move straight upward. That is the cylinder. Let's see, this is the if I here, this is r, sorry, r, this is the theta, and then I move in the vertical direction. It's just like a glass. It's a cylinder. If you want to show a position, that is r theta, and then reach at a particular height of in the glass, cup, these are all cylindrical shapes. Spherical coordinates, sometimes it is easy to show the curvilinear motion in space in the spherical coordinates. The spherical coordinate system is defined by the radial distance r. Again, this point is P. This is r, right? So we define this is the radial direction. This is radial direction, and then this is, and then we move theta in the plane in the case of Cartesian. I say here I shown xy, the angular movement in the xy plane, that is theta, and then I move in the along this from plane to this space, that is phi. Dear student, you just think of the sphere. If I cut a spherical ball, if you cut into half, just like a dome, if I am standing at the center, and if we need to find the position of that particle at the periphery, then it can be represented by, of course, the periphery of the dome is at a radius r, right? Then I move a certain point along the periphery, that is theta. Then I move along the dome periphery in the 3D direction, and that will be the angle. That will be the angle phi. That will be the angle phi. So the angle phi is the angle between this r and, of course, the theta plane. So that is r. Movement along the plane is theta, and movement along the space, that is along the dome surface, that is basically the theta. The unit vector er, e theta and e phi are perpendicular to each other, and their positive directions are direction of the increase of the related coordinates. And I have shown you, that is er, this e theta and e phi, they are all perpendicular to each other. So if I will show the value, show the direction of er, e theta, e phi, so anything in this direction is positive, otherwise it's negative. The unit vector er points the direction in the, which is the r, increase, and theta and phi stays constant. The other two unit vectors are the same way. If I say theta, that is the movement along the theta, other coordinates are constant. If I say e phi, that is movement along the phi, means along the curved surface of the dome, that is basically the phi, and other coordinates are the same. So all the it is just like the er, e theta coordinate. I added e phi coordinate. They are basically again the mutually perpendicular coordinates. If you see here, so this is the if this is the point P, if I need to reach this point P, I move first of all in the in the r direction. Then there is angle theta, right? The r. Then there is angle theta, and there is angle phi. So position vector, if I want to show, it is basically r, er. If I show the velocity, it's vr, er, v theta, e theta, and v phi, e phi. Vr is simple, which I have already written for these polar coordinates, and there's r dot. V theta here, v theta, right? V theta, theta in theta direction is r theta dot cos of phi, because this point is here. We need along that particular theta direction, that is cos of phi, right? Cos of phi will give you this, and v phi is equal to r, right? V phi how changing is r times theta of phi dot, how this phi is angle is going to be changed, because velocity along this direction, how phi is to be changed, that is called r phi dot. So the radial component is r dot, theta component is r dot cos of phi, and the phi component is r phi dot, and of course v r square, v theta square, v phi square will give you the overall velocity. As well as acceleration is concerned, of course, acceleration also has three components: radial component, theta component, and the phi component. AR, we have also written that in the previous in the r theta coordinates, is r double dot minus r but here becomes r phi dot square, right? R double dot minus r phi dot square minus r theta dot square cos square phi. So it is just like the r theta dot square, but here we have two angles. There is a theta dot and the phi dot. So one becomes r theta dot square, then r theta, phi dot square minus r theta dot square, right? Because this is theta and the component of this theta, this angle is theta. The component of this will along this, that is basically phi component along this, so cos square phi. Similarly, a theta is the cos of phi over r, d by dt r square theta dot minus 2r theta dot phi dot sine of theta. We take another, in this case, I'm taking the theta, I take the derivative of this, so it's basically theta dot. So this value becomes a phi is equal to 1 by r d by dt r square phi dot plus r theta dot square cos of phi sine of phi. So simply a r is equal to r double dot minus r phi dot minus r theta dot square cos square theta. A theta is equal to r cos of phi theta double dot plus 2r dot cos of phi theta dot minus 2r theta dot phi dot sine theta. And a phi is equal to r theta double dot plus 2r dot phi dot plus r theta dot square cos of phi sine of phi. So these are the values we use. You not go into very much in detail how I derive these equations, but I've shown you just take the components of that particular value along this, along the particular direction r, theta or phi. Okay, the spherical coordinates application. The spherical coordinates system is commonly used in monitoring the position of planes and space aircraft by radar tracking. For example, this radar is tracking this plane. Now it has become easy to analyze in the spherical coordinate systems. Similarly, if you want to show the position of this robotic arm with reference to the frame, and in this case again the r theta phi coordinates means the spherical coordinates becomes easy to analyze. Let's go to simple problem 2-11. A power screw starts from rest and is given a rotational speed of theta dot, which increases uniformly with time t according to theta dot is equal to kt, where k is a constant. Determine the expression for the velocity v and the acceleration of a of the center of the ball A. When the screw has turned through one complete revolution from rest, the lead of the screw advancement is L. If I rotate it once, it is move in the vertical direction by L. This distance is B, and this is the ball A, and this angular motion along this velocity is theta dot, and this radius is 2r, not dia is 2r, not or r naught. We need to find what do we need to find? The expression for the velocity and acceleration of the center of ball A, the center of ball A, right? So we are given theta dot is equal to kt. The vertical movement is z direction is L. So d theta by dt is equal to kt. So if I integrate from 0 to 2 pi for one revolution, 0 to t kt, integrate, we get the simple relation to this is 0 2 pi is equal to half kt square, t square is 4 pi over k, or t is equal to 2 under root pi by k. Theta dot is equal to kt, and k multiplied with the value of t, which I have find out is 2 under root pi by k. It becomes 2 under root pi k. The helical angle, which is gamma, helical angle means the angle of this thread is basically helical angle gamma, is found by the path followed, as shown in the figure theta z. I show in this figure, right? This tangent gamma is equal to, I show you that this vertical distance is L, right? This vertical distance is L, and the base is how much is rotation is 2 pi b, right? So tangent gamma is equal to L over 2 pi b. Now from the figure, theta is equal to of v cos of gamma. Theta is the component of the velocity is v cos of gamma. So v theta is equal to r theta dot. We also know this. So it is b theta dot. So if I put the value of v theta here, so I can find the value of v theta is equal to v cos of gamma, right? So v is equal to v theta upon cos of gamma, and of course v theta is b theta dot cos of gamma. For one revolution, b theta dot over cos of pi, this is for theta dot, which we have found out in the previous, that is 2 into under root pi by pi k. I put the value here, I get the value of the velocity 2b under root pi by k. Now what is cos of gamma? We know that tangent gamma is equal to L by 2 pi b. We know that tangent is sine over cos. Sine gamma is equal to L by 2 pi b cos of gamma. Cos square is this, right? Cos square, how I find it? Sin square theta plus cos square theta is equal to 1. So sin square theta is 1 minus cos square theta, or cos square theta is 1 minus sin square theta. I put the value here, simplify it, I get the cos of gamma 2 pi b over under root L square plus 4 pi square b square. This is from trigonometric relation. When I know one trigonometric relation, I can find the other. So it's 2 pi under root pi k. I put the value of cos of gamma here. It becomes inverted, and then we get the under root v is equal to under root k by pi L square plus 4 pi square b square. Dear student, this technique we have learned in your FSC classes. If I know the value of tangent theta, so I say sin gamma over cos of gamma is this, sin gamma is this times cos of gamma. I put the value of sin of gamma and sin square theta plus cos square gamma is equal to 1. Put the value of sin or cosine to get the value of cos. Because I need the value of cos, I directly find the value of cosine. So this is the value of the velocity. Similarly, for the acceleration is r double dot minus theta dot square. A theta is equal to r theta dot double dot plus 2r dot theta dot. Az is equal to z double dot, which is this. So ar is equal to r dot is 0 because it's constant, minus b 2 pi under root r theta up to 2 under root pi k whole square, because we know the value of r and we put the value of the theta dot, square it, we get the value. Similarly, a theta is equal to r theta dot. R theta double dot, here r dot is 0, so r is b and theta double dot is k, that we have find out, so it's bk. And similarly az is a d by dz vz, which is d by dt of v theta sine of gamma, which is d by dt of b theta dot tan gamma. So az is equal to b, tangent gamma is constant, it becomes theta double dot, which is equal to b, I put the value of tangent gamma, it's equal to k L by 2 pi. So ar square plus a theta square plus az square, just put the values of all the values. This is ar, and this is the value of a theta, and this is the value of az. Put it here and simplify, we get this result. So dear students, please do with your hand, and it becomes easy for you to understand the things. Sample problem 2-12, an aircraft P takes off at A with a velocity of V0 or 250 km per hour and climbs in the vertical y dash z dash plane at a constant 50-degree angle with an acceleration along its flight path of 0.8 meter per second square. Flight progress is monitored by radar. Right, this radar is monitoring the progress of the flight. Right, these are the coordinates of the plane, and these are the coordinates of the radar. At point O, resolve the velocity p into cylindrical coordinates components 60 seconds after takeoff and find r dot theta dot z dot for the instant. Resolve the velocity of the aircraft p into spherical coordinates component at 60 seconds after takeoff and find r dot theta dot phi dot for the instant. We need to find here the velocity p into cylindrical coordinates and into spherical coordinates. So y dash z dash is the plane axis. The velocity is given to 50 km per hour. I convert into meter per second. Speed after 60 seconds, v is equal to v0 plus 80. Vf is equal to vi plus 80. After 60 seconds, the velocity will be 117.4 meter per second. The distance s traveled after takeoff is s is equal to s naught v naught t plus half 80 square. Of course, there is no s naught. We put the value of v naught of t. V naught is 69.4. 60 second half, and the a is given to us 0.8 meter per second square. Right, a is given to us 0.8 meter per second square, and put the value of time. We get distance traveled in during 60 seconds 5610 meter. The y coordinates and associated angle theta is, the y coordinate of course is 5610 cos of 15. This is the y coordinate, right? This is the y coordinate because distance is this. So I need to find this one. So its cos of 15 will give me the y coordinates of this. Okay. Yes, distance traveled y coordinate is this much, and theta is equal to tangent inverse. We get the angle 540 upon 3000. What is 3000? I'll show you this one, right? This one, right? So this is 3000, 3 kilometer, is 3000, right? So that is the tangent inverse 5240 tangent, and this is this value. This is perpendicular upon, this is perpendicular upon base. 5420 is the y coordinate, right? This is the y coordinate. Height of this plane with reference to this is the y coordinate is this much, and the vertical component is this x component is 3000 to y tangent is y by x is 61 degree is the theta. This angle theta is 61 degree, right? Now similarly, from the figure B of the xy projection, if you see figure B, the xy projection here, right? Of course, the r is equal to 3000 square plus 542 square 6190. I'm saying this value of r, right? So this r will be equal to very simple 3000 square, and then there is 5420 the x square plus y square. So Vxy, the velocity in the xy plane is V cos of 15, which is 117.4 cos of 15 degree after 60 seconds, 113.4 meter per second. The radial component is r dot, which is Vxy sine of theta, right? Vxy is, if you're not understanding, this is the x and y, this is xy component, right? So if I want to take the component along the r direction, so we take the component along this, which is angle is 15 degree. So we find out, Vxy sine of theta angle we find 61 degree, we find 99.2. First we find the projection of the velocity along the xy plane, and then we move in the theta direction, please. In the theta direction, that is 61 degree. And similarly, V theta is equal to r theta dot, with Vxy cos of theta, very simple. That is 113.4 cos of 61 degree, 55 meter per second. Dear student, I'm again explain this one. Okay, this is the if this is the velocity in the xy plane, then we take a projection along the plane, that is the angle is 5, is 50 degree, and now these two components, one is x component, one is y component, and of course x component is cos and y component is the sine, right? We get the projection of the plane and then divide it just like the 2D, the cos of that is the x component and the y component. R component is sine of 60 along the, because it is perpendicular to r, and then along this theta, that is along this, that is cos of theta. So this is the first of all the projection along this, along the plane, space into plane, and then projection is divided into r and theta like 2D. Now the theta dot is equal to, so theta dot is equal to, it is 55 divided by 6190. This is the 6190 and 55 theta, so it is 8.88 into 10 raised to minus 3 radians per second. So from here, what you find, this is 250 km per hour. We are given the values, and this value is theta dot is equal to 55 over 6190, 8.88 10 to minus 3 meter per second square. This is the theta velocity. So V theta is r theta dot. I divide with r, we get the value of the angular velocity. Similarly, finally Vz in this case, of course, we divide this one Vxy. So similarly here Vz is the xy component, and the other component is sine of 15, the z component, that is 30.4 meter per second. From the next figure in the xy plane, then we need to find now the in the spherical coordinates. From the next figure in the xy plane, right? I'm saying this one, this xy plane, in the xy plane, this one is the r, this one is theta, and this one is phi. Phi is along the vertical direction, and theta is on the plane, and r is on the plane. Then the spherical coordinates, this is y tangent 15, right? Same y 5420 tangent 15 degree. that is z, because z is if I'm showing you this is the my z direction. So what we have 5420 which we have find out the distance traveled, right? 5420, that is the y direction. So the sine component will be along the z direction, right? Same, the phi angle is similarly tan inverse z by r, it is 13.2 degree. If you see the figure, so r is equal to, of course, I've already shown you in the when I giving you the concept of the spherical coordinates, r square plus z square, that is the total r. This is the r, this r square plus z square, this triangle is shaded region, right? You can find out the value of r from here. And now from the figure, of course, Vr is equal to, you know, that r dot, which is 99.2 cos of 13.19 degree, which angle is cos of phi, plus 30.4 sine 13.19 degree, that is 103.6 meter per second. So r dot, we have find out it is 29.2, because these all things I have find out using the spherical coordinate which I have shown you on this in this figure. Sorry, I'm showing you in these spherical coordinates, right? This one, this is ar, r double dot r theta dot minus r theta dot square cos square theta. Similarly, we are showing the other one. So we have find out the Vr. Similarly, theta dot is 8.88 extra minus 3 radian per second, that we have find out in the previous section. So V phi is equal to r phi dot, there is 30.4 cos of 30 minus 9 point sine 13.19 degree. Dear students, basically this is the r. If I show you, sorry, this is the radial component Vr. We are talking of the velocity in the r direction, right? So one is the in the r direction. If I know the velocity in the v in other direction, to take the components of along the phi, right? One is positive and other one is a negative, right? This is 30 cos of 13.9 and 99.9 13.19 is a negative direction. So therefore that is 6.95 meter per second. And similarly, r phi dot, we know that we can find the phi dot, that is the angular velocity in the phi direction, 1.093 x minus 3 radian per second. Okay, thank you, students. We have completed the solved problems. Let's go to some unsolved problems. This is problem 2-171. That is from 6th edition. The rectangular coordinates of a particle are given in millimeters as function of time t in seconds. By x is this 30 cos of 2t, y 40 sine of 2t, and z is equal to 20t plus 3t squared. Determine the angle theta between the position vector r and the velocity vector v, and the angle theta 2 between the position vector r and acceleration a, both at time t is equal to 2 seconds. So we are given the value of x is 30 cos of 2t. I take the first derivative, it becomes minus 6 sine 2t. Similarly, take the second derivative. Similarly, here y, I take the first derivative, take the second derivative. This is z, I take the first derivative and take the second derivative. As we need to find the values at 2 seconds, so I just put the values of 2 seconds in x dot, x double dot. Similarly, y dot, y double dot, and z double dot. I find the values of the components of the in the 3 directions. So if I need to find r, is the x square plus y square plus z square. This is the value of the r, 63.3 millimeters. Velocity, of course, 76.3 millimeter per second. And acceleration is also x double dot square, y double dot square plus z double dot square is 144.4 millimeter per second square. Now the question is now to find theta 1. Remember that, students, when you need to find the angle in the 3D, you take the projection along this, because we need to find the angle along the velocity. So this can be written as that we take the we will take the dot product of r and velocity. R dot v is equal to r dot v is equal to r into v cos of theta. So from here, okay, So by taking the dot product, we can find the angle between the r and the velocity, and similarly we take the dot product with r and acceleration. We find the angle between r and acceleration. Dear students, let's move to problem 2-172. An aircraft takes off at A and climbs at a steady angle with a slope of 1 to 2 inch in the vertical YZ direction at a constant speed v is equal to 400 km per hour. The aircraft is tracked by radar at O for the position B. Determine the value of r dot, theta dot, and phi dot. We are tracking the radar. We are here. The radar. This is the, of course, x direction, y direction, the z direction. This is r. This angle it shows is phi, right? So it is theta dot is given. This is the angular rotation of the radar, right? And the aircraft is moving here, and this is the slope of the aircraft which is moving in this direction, which is 1, and this is 2. We need to find r dot, theta dot, and phi dot. So if you see this is the direction. This distance is 500. This is 300. This angle is phi. This is the velocity of the plane. This is v cos of beta. Of course, this angle is beta. This is cos of beta. With this angle can be found out from here, which is 1, 2. So beta is equal to tan inverse 1 by 2, which is 26.6 degree, and phi is equal to tan inverse perpendicular upon there, 431 degree. This phi is this much, and beta is this much. So VR, what do we need to find VR? VR is equal to 400, right? What is the given? The velocity is 400 km per hour. So we need to find the velocity along this radial direction, right? So of course 400 into, first of all, the 400 into the direction along the beta, and then along the r, so that will be equal to sine of 26.6, and then we take its components along the r, which is sine of 31 degree, and that is VR, which is r dot 92 km per hour. V is equal to VR, ER, V theta, E theta, and V phi, E phi. VR is equal to r dot, V theta is equal to r theta dot cos of phi, and V theta is equal to r theta dot. But we know that. So V theta is equal to r theta dot cos of phi. So V theta is equal to 400. We have done cos of 26.6 degree, because we need to find the velocity in the theta direction. So this is the in the theta direction, that is 400 cos of a simple 26.6 beta. We get the value in the theta direction. So V theta is equal to r theta dot cos of phi, and then from here you can find the value of theta dot. This is one of the unknown required. Similarly, V theta is equal to r theta dot. So V phi is 400 divided by 3.6. I convert it to meters per second, right? This is sine of 26.6 and cos of 31 degree. In the same way, which I find out, first of all, I have taken the sine of a 26 along the beta, and this is the angle phi in this direction. So a cos of 31 degree will give the cos component, and sine of the 31 degree give the r component. 400 phi dot, and phi dot is equal to 0.1 radians per second. Let's see the problem 2-16. It's just like you see the rotating element in a mixing chamber is given a periodic axial movement z is equal to z naught sine 2 pi nt, while it is rotating at a constant angular velocity of theta dot is equal to omega. Determine the expression for the maximum magnitude of acceleration of a point A, right, of point A on the rim of the radius r. The frequency n of the vertical oscillation is constant. We are given z is equal to z naught sine 2 pi nt, right, and this is rotating with omega, and this radius r. We need to find we need to find the acceleration of the point A. It's just like anything rotating, like in the case of spinner, like in the case of mixture, like in the case of the mixture that you have at your home. So that is the practical problem that mostly we come across. AR is equal to AR is r dot minus r theta dot, which r dot is 0, that is r omega minus r omega square. A theta is equal to r theta dot plus 2 r dot theta dot. So because this is moving in a, I'm talking of in the plane to 2 r dot theta dot. So r double theta double dot is 0, and r dot r dot is 0. So we call r is constant 0. So what about the velocity? So now as far as the velocity in the z component, of course d by dz, we got given the value of this z naught sine 2 pi nt. So 2 pi nt z naught, of course cost of 2 pi nt. So az, I take that again the derivative of this, Vz, we can minus 4 pi square n square z square sine 2 pi nt as cos of 2 pi nt is minus sine of 2 pi nt. Of course, the a acceleration a square, a theta square, a z square, just put the values here. For all the values here, we get this. For n is equal to 1, the acceleration reduced to r square omega 4, 16 n 4 pi 4 z naught square. Let's go for the problem 2-171. It's from 7th edition. A car A is ascending a parking garage ramp in the form of a cylindrical helix of 24 feet radius, rising 10 feet for each half turn. At the position shown, the car has a speed of 15 miles per hour, which is decreasing at the rate of 2 miles per hour per second. Determine the r, theta and z components of the acceleration of the car. And this is basically, this is a parking lot in which the car is moving in a helix, of course, and of course in the half rotation, it is basically in the vertical direction, it is basically ascending at the rate of 10 feet per half return. The diameter, radius of this cylinder is basically 24 feet. So this equation can be solved. Now, of course, in the cylindrical coordinates, first of all, you find the helix angle. So helix angle can be found out. R is equal to tan inverse 18 upon 24 pi. Right? Why we say 18 upon 4 pi? Right? This is the helix angle. Right? This is the helix angle. So what we have in the helix angle is tangent in R is tangent inverse. If I need to find the value of R, this is R, and this is the y direction, and this is this direction. So this is equal to 18 2 pi 24 pi is 7.55 degree. So helix angle, which I find out from here, that is this much, right? This much. This is this much. If you see, this is 24, and this is this, because it's taking the half revolution. One revolution is 2 pi r. 2 pi r. So it's a half revolution. So r is 24, which is basically 12. It becomes 12 pi r. So it is 24. 24 pi is this much, right? And I'm sorry. So this is the revolution along this, right, which is 24 pi distance traveled along this, that's and this helix angle, and then it's 18 we find out with the help of this, right, that is from the triangle made by this. So it's 7.55 degree. So V is equal to 15. I convert it into feet per second. 5280 3600 22 feet per second. This is 15 miles per hour. To 5280 divided by 3600 22 miles. 1.6 1600 meters multiplied by 3.3 feet. Of course, divided by 3600 to 22 seconds. So this is the velocity. This is the r theta dot. This is the z component. So Vz is equal to V sine of gamma, which becomes 2.89, and V theta is equal to V cos of gamma, right? So we know that V theta is equal to R theta dot. So theta dot is equal to V theta by R. So I know the value of theta, that we can find the value of the theta dot. Similarly, A theta z, it is A theta z is basically 2 times of 5280 3600. It is 2.93, right? That is the velocity R theta dot, right? This is 2 feet because it's decreasing by 2 feet per second square, so it is 2 multiplied by the radius, this angle we can find in the conversion factor. This is a feet per second square. It's giving that the z is decreasing 2 miles per hour, right? Now let's go for the radial direction, for the angle. This is the radial angle, right? It's going inward, of course, towards the center, to the center. So this is A theta, this is AR. So A theta is equal to minus 2.93 cos of 7.55 degree. AZ is minus 2.93, just like here. Only the negative components. AR is equal to R double dot 1 R theta square, R double dot 0, R is equal to 24, and theta dot is 0.901, which is given to us. That is the minus 19.82 feet per second square. We have the value of, I think, theta dot, which is 0.909, right? So we have find out these components. So these are the requirements. We have to find the acceleration. If you need to find the overall acceleration, take the squares and take the root, and you get the answer. Okay, so that is the value which we have. Okay, dear students, now move to the next problems. Problem 2-177. The base structure of the fire truck ladder rotates about a vertical axis through O with a constant angular velocity omega 10 degree per second. At the same time, the ladder units OB elevates at a constant rate of 5.7 degree per second. And the section AB of the radar extend from within section OA at the constant rate of 0.5 meter per second at the instant under consideration. Phi is equal to 30 degree, O is 9 meter, and AB is equal to 6 meter. Determine the magnitude of the velocity and acceleration of and P of the ladder. This is a fire extension actually, and that is the point B. We need to find this is the section C. It is rotating about this axis, right? And then this is the angle theta, and this angle is theta, which is lifting up this, and this angle is phi, right? The two angles. One is along the base, right, which is moving on along the surface of the vehicle, and now this is the angle which is rotating in the vertical direction, right? So these questions can be solved in the spherical coordinate systems. So we go for the VR. VR is r dot 0.5 meter per second, which is given to us, which is 0.5 meters per second. It's 0.5 meter per second, constant rate of 0.5 meter per second, right? And then V theta is equal to r theta dot cos of phi 15, again 10 pi by 180 into cos of 10 pi by 180 cos of 30. That is 30 degree angle is given to us, right? This is cos of 30, which is phi, right? And the other things are also given to us. So we are, it is r theta dot. Theta dot you can find out from here is 10 degree per second. I convert into radian per second, right? It's pi by 180. I get the V theta. Similarly, phi is r phi dot is 15. Phi dot is also given to us is 7 degree. So I convert into radian pi by 180. You get the value of the phi component, right? Which is the rotation along the space, right? So velocity is VR square, V theta square, Vz square. We get the value of 2.96 meter per second. Now the AR is R double dot minus R theta dot square minus R theta dot square cos of phi. R double dot 0, that is 15. We given the theta dot. We put the value of this here. Minus R 15. This is the value of theta dot. We have also find this one. It is 10 phi by 80, which is given to us. 10 degree cos square cos of phi. Cos square 30, so that is the value of the acceleration is 0.567 meter per second square. This relation we get from the previous section that we have learned in the initial section of the lecture. You can take from this. A theta is equal to cos of phi by r square theta double dot plus 2r dot theta dot minus 2r theta dot phi sine of phi. I have cos of 30 by 15. R is known. And theta double dot is 0. It is 2r. R dot is known. Theta dot is known. Everything is known. This term goes to 0. We get A theta is equal to minus 0.1687 meter per second square. Now, what is A phi? A phi is equal to 1 by r square phi double dot plus 2r dot phi dot plus r theta dot square sine phi cos phi. Again, we plug the values. We know all the values here. We know r. We know the phi dot double dot is 0 because phi dot is given to you constant. Second derivative is 0. We know the value of r dot phi dot is 7 degree. So we have the value of theta dot and the phi angle is 30 degree, and we find the value of A phi. And for the same value, AR square plus A theta square A phi square, we find the net acceleration of this fire extension. So let's move to problem 2-181. The design of an amusement park died. The cars are attached to an arm of a length r, which are hinged to a central rotating collar, which drives the assembly about the vertical axis with a constant angular rate omega is equal to theta dot. The car rises and falls with a track according to the relation z is equal to h by 2 1 minus cos of 2 theta. Find the r, theta and phi components of the velocity v of each car as it passes the position at angle of pi by 4 radian, which is 45 degree. So this is the amusement park. That basically these cars are moving, right? And this, if you take this track, is sometime rising and sometime decreasing. I think you have come across this phenomena and this ride in some amusement park, right? This angle is theta, that is the angle theta, and this angle is phi, right? This horizontal r, and then z, this angle is phi, and this angle is theta on the plane, and that is the height of this plus height h or minus h. It's increasing and decreasing, and first of all is moving in this direction with the velocity v. So r is constant, it's not changing. Theta is equal to omega t, and sin phi is equal to z by r. This is phi, this is z, therefore this is by r. Sin phi, that is basically z by r, that is perpendicular upon hypotenuse, right? So z is equal to h by 2, 1 minus cos of 2 theta. This is given to us, so I take the first derivative, it is z dot is equal to omega h sine of 2 theta, where theta dot is equal to omega. We take the derivative and we get this one, right? So we have given here, I think so, this is z, h by 2, 1 minus cos of 2 theta. This is the value of this figure, right? So z is equal to h by 2. If we take the time derivative, so this becomes h by 2, 1 is 0, cos of 2 theta becomes sine of 2 theta, right? Minus sine of 2 theta becomes plus, and then 2 theta it becomes 2, which is 2 to cancel out, and of course, and then is theta dot is written as omega, right? So this is the way how to take the derivative. Now cos of phi, then phi dot is 1 by r z dot, right? 1 by r z dot, again take the derivative of this one, right? So sine of phi is cos of phi, and phi is also time dependent, is phi dot chain rule. So that is 1 by r, and then the r is constant, z is dealing with z dot. From here I can find the value of phi dot, wh sine 2 theta by r cos of theta. R dot is 0, v theta is equal to r dot cos of phi, so it is r omega under root of 1 minus sine square phi. So v theta is equal to what is, where is v theta? V theta is how much? V theta, yes, v theta is equal to hw, and this is the value of cos of phi, right? So this is the value of the cos of phi, theta dot. From here, this theta dot can be written as theta dot is z by this. So hw sine of 2 theta 1 minus h by 2 r, 1 minus cos of 2 theta whole square. Because this is the value of r, right? And then this is the w, and then I find out the sine of 2 theta, 1 minus sine square theta, and put the value of here, we get the value of v theta. Similarly, when theta is equal to omega t is equal to pi by 4, 1 minus cos 2 theta, because cos 2 theta, pi by 4 becomes pi by 2 becomes 1, that is 90, cos 90 is equal to 1. So this v theta is equal to r omega, so this term goes to 1, 1 minus is 0, this whole term becomes 1. So this becomes very simple, which is h omega 1 minus h by 2 r whole square, 1 minus cos of 2 theta, because cos we have find out cos of 2, we have only sine of 2 theta, which I find out from here. So v theta is equal to, in v theta, right, in v theta, so v theta is equal to this much, v phi is equal to h w by 1 minus h by 2 r square, right? Sorry. So this is basically v phi, so please correct it, this is v phi, this is not v theta. So v phi this, so hw by 1 minus this, vr is equal to 0, so vr square plus v theta square plus v phi square, because vr is 0, because r is constant, there is no changing in the radius, so therefore this. So this is vr 0, v theta we have found out this is v phi, sorry, please correct it, and that is the result. Thank you very much, students. So this is completes your curvilinear motion. We talk of the curvilinear motion in Cartesian coordinates, in normal tangential coordinates, in polar coordinates, and today I discuss all the curvilinear motion in space on all the 3 Cartesian, polar, and the Cartesian, cylindrical, and the spherical coordinates. So next lecture we will discuss the relative motion and then the connected motion of bodies. Thank you.